Traditional VPN access usually works like this. A user connects, and then they receive a route to a private network or subnet. That model is familiar, but it has a major limitation. The access decision is often made at the network level. So if a user needs one internal application, they may end up with access to the broader network where that application lives. Giving them access to the surrounding network creates unnecessary exposure and increases the risk of lateral movement. Zero Trust Network Access, or ZTNA, takes a different approach. Verify the user, then grant access only to the applications that person is authorized to use. OpenVPN Access Server can apply this model by acting as an identity-aware access broker. Instead of placing users on the private network, it brokers connections to specific applications. In this tutorial, I'll show you how to configure application-level access globally, by group, and for individual users. The result is least privilege access without exposing your private subnets or application server IP addresses. Let's get started. First, let's look at the traditional VPN model. This access server currently has a subnet-based access rule for 192.168.0.0/20. When a user connects, that route is pushed to the user's device. I'll connect using the OpenVPN Connect app and open the connection log. Here we can see the route for 192.168.0.0/20 being added. If I check the device's routing table, the same private subnet appears there. The user may only need the company timecard application, for example, but the VPN has given the device a path to the entire subnet. That also reveals information about the private network and may allow the user or a compromised device to discover other systems. Before we start adding applications, let's do a quick settings check. In Access Server 3.1 and newer, the DNS server Proxy is set to auto by default. We're not changing the default, we just want to make sure someone hasn't changed it. In the Admin Web UI, go to Access Controls, open the Internet Access and DNS tab, and find DNS Server Proxy. Confirm that it's still set to auto. If it is, you're good to go. If it has been changed, switch it back to auto, then save and restart the services. Step 2 is to decide the scope, because domain rules can live at 3 levels: globally for all users, per group, or per individual user, and you can mix all 3. A global rule is the fastest way to route a shared service like your company wiki for everyone. Group and user rules are where least privilege really pays off. For example, accounting gets the accounting app's domain, sales gets CRM, and nobody gets a subnet. Think about which resources are truly universal versus which should be scoped, because that decides where each rule goes. Step 3 is adding a global domain rule for the resources everyone needs. In Access Controls, open the Global Access Rules tab, and under Domains, pick your reachability mode NAT. Then type the domain into the Domains field for this demo. I type timecard.nobase.local and save and restart. Step 4 is scoping a rule to a specific group or user. Head over to Groups or Users, pick the one you want, open its Access Rules tab, and click New Access Rule. In the Address field, you enter the domain. So for the accounting group, I'll enter the accounting app's domain, which is accounting.nobase.local. Notice that the protocol and port fields gray out. That's expected, because domain rules don't do port-level filtering. Now here's a nice trick. I'm also going to add a SaaS application, and for this demo, let's use SharePoint. I've already added my Access Server's IP to SharePoint's allowed network list, so I'm adding another layer of security to my public apps too. Users have to be connected to the Access Server before they can reach it. Go ahead and save the rule and restart. Then just repeat this per group, so each team routes only its own applications by name and nothing else. Before we move on, let's try to open SharePoint. As you can see, our access is blocked, because we're not connected to the Access Server yet. And you can do this with any SaaS application, as long as you're able to add the Access Server's IP to its allowed list. Step 5 is test from a real client. Connect a user and confirm they can reach the domain you granted. So let's connect as Sean. He is part of accounting, so he has access to Timecard, which is a global access rule, and to Accounting App, which is a group access rule and has access to SharePoint. And here's the payoff from our opening demo. Pull up that same connection log again. We can see the root here and run the same root check. The 192.168.0.0/20 line is gone. There's no private subnet in the client's routing table at all, just the app reachable by name. Same access for the user, zero exposure of your network. Let's try SharePoint. We should be able to connect since we are connected to Access Server. Same access for the user, zero exposure of your network. So, to recap, make sure the DNS server proxy is on, decide whether each resource is global or scoped, add domain rules at the right level, pair them with split tunnel for the tightest result, then save, restart, and verify from a client. The payoff is real. Your users reach applications by name, your private subnets are never pushed as routes, and there's simply nothing on the wire for an attacker to scan or map. That's least privilege without ever exposing your network. Thanks for watching, and I'll see you in the next one.